The very last thing, what we talked about last time was about this business about combining DFAs together using intersections and unions. Maybe I will just to conclude that discussion, I'm going to write the upshot of all of that as a theorem. And this is a theorem about the closure properties for regular languages. And it just says something like, if L is regular, then L bar is regular. I'm not going to try to write proofs of these things, but each one you should remember the procedure. So what this means is if you have a language which is accepted by a DFA, then you can make a DFA to accept the opposite of that, the complementary language. And the procedure for doing that is you just swap all the accepting versus rejecting states. And then also, so that's one thing, and then also, if I have two regular languages, L1 and L2 are regular, then L1 intersect L2 is regular, and L1 union L2 is regular, right? And for these also, I would not expect you to write a proof of these things, but you should remember the procedure by which you can take two DFAs and create a DFA for their intersection of their languages. That's what we call the product construction with the pairs and all that. And a simple variation gets you the union. You'll have some practice with those on the homework from last time. All right. I just wanted to have this in writing as a summary of what we finished up towards the end last time. And with that, I want to talk about a new type of machine. We've been talking about DFAs for the whole time, basically. I want to talk about another kind of machine. Throughout the course, we're going to be talking about several different sort of types of machines of increasing complexity, eventually talking about the Turing machine. Another kind of machine. This one is very much like the DFA, except for the D. This is called the NFA. So it's like the DFA, but instead of the D, we have the N. Remember, DFA stands for deterministic finite automaton. Finite just means there's finitely many states, which is still true of the NFA. The difference for the NFA is the N, and the N stands for non-deterministic. So the D before, the fact that they were deterministic, or we call them deterministic, really is because of the rule about every state has to have only one outgoing arrow per letter. NFAs are not like that. So in a non-deterministic machine, what this means is the transitions may not be unique for each letter. What I mean by that? For example, here is, this is a legal NFA. It's not legal as a DFA though. How about that? This is an NFA, which is illegal as a DFA because X has two outgoing B arrows, and that's not allowed for a DFA. But this is a valid NFA. And here, what's interesting about it is from X, the B transition can lead to X or Y, right? There's a B arrow from X going back to X, and there's also a B arrow going over to Y. All right. This kind of thing is not allowed in a DFA because of the determinism, but it is allowed in an NFA. So non-determinism, you can imagine what this means is like if you had such a machine in real life and you were in state X and you see B, then the interpretation of this is, well, maybe sometimes it would go back to X and some other times it would go over to Y, but you don't really know what's going to happen. That's why it's called non-deterministic. All right. This is the difference between an NFA and a DFA. because of the non-determinism, you may wonder about like what does it even mean for a string to be accepted or not? Because of this non-determinism, you might feel like certain strings, like maybe they are, maybe they aren't. How can you tell? The way that we tell, we say in this in an NFA, we say a string is accepted if, sorry, my handwriting here, any of the possible final states are accepting. All right. A string is accepted if any of the possible final states. You know, when I give you a string on an NFA, there's actually several ways that you could read through that string, following different arrows maybe from one strategy to the next. We say it's accepted if any one of those possible ways of reading the string leads you to an accepting state. All right, this is how an NFA works. So for example, in that example, maybe I'll just write it again so that we can see it here. So here, something like AABAB, this is accepted because it is possible to follow the arrows and end in the accepting state if you're reading this string. You can go AABAB. I have to do all of them on this loop. AABA, and then finally go across for the last B. All right, so this one is accepted because it is possible to end up in the accepting state. Can anyone give me an example of something which is not accepted? Or maybe anything is, yeah? AAA, yeah, this is not accepted. Because there's no way to get to here after having read AAA, right? The only way to do that is AAA like this. Or something like ABA, this also is not accepted because you cannot make ABA and end up over here. You could go across with the B, but then actually something weird. This state has no outgoing arrows at all. That also is allowed for an NFA. Just means once you do this B, you better be at the end of the string because you can't go anywhere else from there. All right, so ABA also is not accepted. All right. Can we say, perhaps, like in words, how would you describe all the strings which are accepted on this thing? Volume. Any thoughts? What kinds of strings are accepted? Yeah? XB. Yeah, I like that. I was going to say in words, any string ending with B. Right? If you wanted to write it as a set, this is the way I would write it. XB, where X is in AB star. Yeah, great. Any string ending with B. This can be a little confusing when you sort of start thinking about NFAs, but to me, actually, I find NFAs a little easier to understand when I'm looking at this picture. When I see this loop AB here, that just means you can do whatever you want, as many letters as you like, but you got to finish with a B, and then it'll be accepted. To me, that's actually a very readable kind of diagram. As opposed to, if you made a DFA for this language, actually it would have to be a little bit more complicated. I prefer the NFA for this particular language. All right? This one accepts any string ending with a B. How about, maybe I'll give you all a moment to try this. Can you come up with an NFA which accepts any string beginning with a B? So it starts with a B and then has, anything else? If you wrote that as a set, it would say BX. you can make kind of a variation on that one there. Is that enough time? What do you think? Can anybody just describe in words what you said? You got to do B first and then anything. That's the idea. Anyone come up with anything? Yeah?
I just moved the loop from the one we were talking about before to the next state.
A loop over here?
Yeah, so it would be A, comma B, and then get rid of the A, comma B on the other.
Yeah, yeah. Great. So, yeah, I would say it's exactly like this, only this loop should be over there instead of at the beginning. Yeah, I hope that you said something like that. B first, and then anything. Yeah, this is how I would draw it. There are other ways you could draw an NFA for this. Yeah.
If you get like an A in as your first letter, what happens?
Yeah, so this is a weird thing about NFAs is sometimes you can just get stuck. So like if I ask you something like, is AA accepted? The natural way to do it is, okay, you sort of start here and you do A, and A don't go nowhere from there. Yeah. So the interpretation of this is, remember what it means to be accepted on an NFA is there is some way to read through the string and end at the final or the accepting state. And that is not true of this string. Like you can't even read it at all. Yeah.
Then for this, do we even need the A, B circling back into the second state? It's like it doesn't matter?
You do.
Okay.
Yeah, so is AA is accepted? The answer is no, because it gets stuck before you can read the whole thing, right? And that also is why you need this loop here.
In my head it was like, it's already in there, so if it gets stuck, it's fine. But
that's right. Yeah, you have to actually read through the whole string and end up in the accepting state. So here, AA is accepted, no. And also, for instance, something like, well, yeah. His question was, what if I omit this, is it still okay? And the answer is no, because then if you omit this, then the only thing accepted will be just B. You're not allowed to do any more stuff because you'll get stuck after that. All right? Great. So, you'll have to, with some practice, I think, it's not rocket science, but you'll have to sort of get used to reading NFA diagrams. They are similar to DFAs, but, they work a bit differently. Generally speaking, NFAs are typically simpler, as diagrams. Simpler diagrams than DFAs for the same language. Come on now, sorry, the same language. For example, if I was talking about, let's say the language is all let's say all X where the second to last letter is A. All right, can we make a DFA for that and also an NFA for that? I want to try and compare like sort of which is easier to do, a DFA or an NFA. The DFA for this is actually kind of a pain to do. I think this is the simplest way that I could think of making a DFA here. So if you see A and then something else, it should be accepted. Something else this way, that should also be accepted. Here, I'm going to write down all my whole diagram and then try to say what is the meaning of all these arrows. This is the diagram that I have. I'm going to move it so it's not on the page break. All right. What the various states mean to me is So here's an A followed by another A. This means that there was, well, I would say this state represents strings which end in AA. The only way to get here is if you had two consecutive A's, either AA like that or AA like that, right? So this state represents strings which end in AA. And of course, if you see another A from there, if you end in AA and you see another A, then it still ends in AA. And then this state would represent strings which end in AB. This should still be accepting because I'm trying to accept when the second to last letter is A. But if it ends in AB and you see a B, then it goes back as if there was nothing. If it ends in AB and you see another A, it should go here, which would then allow you to lead into here. I'm just trying to say, this is a fairly complicated DFA, and it would probably take you, I mean, I'm sure we could all come up with this on your own, but it might take you a few minutes of thinking. It's actually much easier to make a NFA for this language. The second to last letter is A. We can make an NFA, so that was a DFA, which is fairly complicated. An NFA, in my opinion, is much easier for the same language. The second to last letter is A. That means the way I think of this is in order to be accepted, I can do A and then something, and then it should be accepted, all right? And I can do, at the beginning, can do whatever you want. So the way that I think of this NFA is, for starters, you can do whatever. But in order to become accepted, you do whatever you like at the beginning, but then you have to do A and then something else, and it should be accepted. To me, this is very clear to understand what's going on here. Whereas this, I mean, I can understand it, but it's quite a bit more complicated. All right. So generally speaking, NFA diagrams can be simpler than the same DFA diagram would be for the same language. All right. Any thoughts about that one? I got a few that I would like you to try. I give you a language and you try to draw a NFA diagram for them. You can try to be inspired by the ones we've done so far. ABXA, so that means it starts with the A and then a B and then it has whatever and then it has an A at the end. So this last one I wrote in a somewhat strange way, but actually we're going to use notations like this fairly often going forward. A comma B squared star. Remember, the star means all possible repetitions of these things, or all strings that you can make using A's and B squareds. So this would include things like ABB. That's a A followed by a B squared. But something like BAB is not part of this language because you can't make that in terms of A's and B squareds together. Anyway, see what you think. I'm going to come around and see how you're doing in a moment. Feel free to chat with your friends about it if you got them. Just looking at how you're seated, it seems like most of you do not got them. But you can make some new friends if you want, or not. I certainly don't got them. It's all right. the last four due That's not what I meant. Yeah, I guess it's ambiguous the way I wrote it, but I meant for X. X can't have B's in it too. Like that? Yeah. And in the second one here, I intended to say that X is also in A, B star. I don't mean that X is only made up of A's. I mean that it's some string which has an even number of A's in it. That's great. Good. This one was great. All right. Okay. Because this makes it so that you're allowed to have someone else's name, which you're not allowed to. All right. Well, this is okay. How's it going? That's good. Yeah, great. Still good there? Yeah, that's where we're at. Still good? Yeah, that's good. Yeah, that's very good. So this should say. So actually, without the comma, this is correct. This means any strings which is made up of A's or B squares, some combination. So for the like A, B squared, A, B squared, B squared, something like that. Which is not bad. Still good here? I would say when you see this even versus odd, you should always think two things come right together. So that's part of it. Still good here? So I like this. You should, to get this even number of A's, you should think about sort of bouncing back and forth.
The problem is like you need a B at the end, but like
Mhm.
B can be any multiple number, so.
We could
Oh,
take
because,
it.
but it's an NFA, so we just throw B's like randomly in if
That's right. Yep.
it's two, so then B's accepted.
Yeah.
Okay.
Mm-hmm. And you need another. Yes. Yeah. Perfect. Still good there? Maybe. This doesn't quite make it, so there has to be a B at the end. And this one, like, since it's got to be a, you can just not do it. I would say make this instead just like a blow off too. How's it going now? Even number is. I love this finishing this meeting. For the even number base part, I want to see, whenever you see like evens versus odd, you should have two states where it goes back and forth. So this basis like, make A go here and then another A go back. Maybe a number of is one so that the A's just go back and forth. So if you have an extra A there, then it allows you. That's how's it going? Yeah, that's great. Still good here? Progress.
Here's the, could be modified in some ways. Use it b squared as an L or no?
All right, can we talk about these? Because we got to go in a few moments. Everybody did great on the first one. The first one you can see, this is, I kind of like NFAs. Is a little personal confession. I kind of like NFAs better than DFAs. I find them a little easier to visualize. Like when I see this, I can very easily translate that directly into an NFA diagram. It has an A and then a B. So it's like this, then a B, then X, which is like you can do whatever you want, which is represented like that. Then finally an A, and it's accepted. So pretty much everybody wrote that for the first one. Excellent job, everybody. The next one, XB, where X uses an even number of A's. So when I see anything involving like evens versus odds, I always think of that. So this is just straight up an even number of A's. But I want, like I said before, the X in this problem isn't just an even number of A's. It could also have B's in it. So I'm going to add in things like that to allow for some B's inside of those even number of A's. And then you want it to accept only if it ends up with a B at the end after having an even number of A's. And the way to do that is like this. I saw a lot of people came up with this. Sorry, that's a little sloppy. All right, so this one, it has to end with a B, and it has to end with a B only having an even number of A's. That's why I drew this arrow from that state rather than from that state, because I want it to only be successful after an even number of A's. All right, great. And the last one is A comma B squared star. So let me just reiterate like what that means. This means any string built from A and B squared. All right, so it's any string that you can sort of make in blocks where each block is either A or a B squared. But you cannot use like individual stray B's. Every B that appears has to be part of a B squared. All right. I think I can do this in 2 states. This is bold. Did anybody do this in 2 states? Yeah? What'd you say?
2 states.
All right, 2 states, yeah.
B's going between them.
B's going back and forth, yeah.
And then an A looping on one of them. And accepting on that one.
Yeah, this is what I had in mind. There are other ways to do this that are less compact than that, but I think that this works. So it starts off right away being accepted. That's because actually, like the empty string is part of this set, and then any individual A will be accepted. You can do B's also, but you got to do 2 B's at a time. So that's why this goes off to a rejecting, but then comes back to the accepting. Yeah, that's great. Excellent. Any thoughts about any of those? We got 5 more minutes, and I got one more thing to tell you in 5 minutes. Probably less than 5 minutes, I can tell you. There's actually one more thing that is allowed in an NFA that I haven't told you about yet. NFA also allows what we call spontaneous transitions. Spontaneous transitions. Spontaneous means like something just happening on its own out of nowhere. That is a transition which does not use any letter from the input string. And we also, these are colloquially referred to as epsilon transitions, because we write them using the epsilon, which epsilon represents the empty string, right? So this is a transition which uses no letter. For example, here is an NFA which uses some epsilon transitions. So those epsilons mean you can just go across that arrow whenever you want without using up any letter from the input string. All right, so this accepts something like AA. How is that? Well, you start in the starting state. Whenever you want, you can do these epsilons for nothing, right? These are like for free. You can just go to this other state instead and then do AA and it will be accepted, all right? You could, if you want, do the epsilon down here, but if you're trying to read AA, you're gonna get stuck, so that's not a useful way to go through the diagram. But this does accept AA or BBB, right? BBB, to accept that, you would do this epsilon first, followed by 3 of these B's. Can anybody say what are the strings, generally speaking, that this accepts? Yeah?
A to the n or b to the n?
Yeah, it accepts any string that looks like a to the n or b to the n, right? It has to be just all a's or all b's. No combination of a's and b's, though, because you have to do one of those epsilons first and then stick with your letter, either a's or b's. How about just a simple variation on that? And then that'll do us. I'm going to draw the same thing. Like that. So the only thing I did was I added that vertical epsilon in the middle there. Now what's different? Can anyone say in our remaining 2 minutes? What's different about this one? Actually, there are some strings which are accepted on this which would not have been accepted before. Can we give me an example of a string which is accepted on this one, but not the other one? Yeah.
Like AB.
AB, yeah, that's an example of one which is accepted here, because you can go epsilon followed by A, followed by epsilon, followed by B, right? So AB is accepted here, even though it's not accepted on the previous one. What about BA? I think actually BA is not accepted here, because if you want to do B, you have to go down here. You can do B, but then there's nobody to get up there to do a A, all right? So AB is accepted, BA is not accepted. In general, we got to go, I'll just tell you. Maybe you all know and didn't want to say it. It's this. It can have A's first and then B's, all right? And as always, either or both of these exponents is allowed to be 0. So it could be all B's if you want, or all A's. But it has A's first followed by B's. It does not have any B's before A's. All right, I think that'll